Hey guys, welcome to Selective Preparation Power Mathematical Reasoning for Test 26. We're just going to go through some questions in this test, and hopefully by the end of it, you guys are a bit more accustomed to solve some questions. Now, let's jump straight in. Question number 1. Together, David, Kim, and Steve weigh 158 kilograms. David weighs 3 kilograms more than Kim and 4 kilograms more than Steve. How much does David weigh? Now, these sort of questions we have to tackle by defining terms in defining numerals in terms of what we want to find. Okay, so what do I mean by that? I mean, if we're given that David weighs 3 kilograms more than Kim, we have to define Kim, or K, I'm going to call it, as D minus 3. Okay, you might say D equals to K plus 3, and that's completely fine because you can use that method in the same way I'm going to use this, but I'll show you why I'm using this. So anyways, I'm defining K in terms of D because I'm trying to find out how much David weighs, right? So I'm not wasting any time. So K equals to D minus 3. Now, then we have Steve. Steve is D minus 4. So 4 off of David, right? And what do we know D to be? We know David is just David, okay? And I state that because it's clearer for you guys to see that now, imagine I add all of this, okay? Then on the left side, I have K plus S plus D. K plus S plus D is what? Is equal to D minus 3 plus D minus 4 plus D, which actually, if you work it out, is 3D minus 7. Now, we're left with a lot of pronumerals, and you guys are wondering, whoa, what was the point of all of that? Well, it's because we have the clue that David, Kim, and Steve all together weigh 158. So now I can make this into a number. K plus S plus D therefore is 158. 158 equals to 3D minus 7. Can you guys see where I'm going with this? Because 3D minus 7 is 158, it must mean then that 3D is 158 plus 7. So I'm adding 7 to both sides, right? As I'm going to the next step. Then it's going to be what? 165, and therefore D is going to be 165 divided by 3, because remember I'm trying to get rid of the 3, which I get 55 years old. Not years old, whoops. Kilograms, okay? And that corresponds to option C. That's how we solve our relative questions. Next, we have question 3. A flight from Sydney to Adelaide takes around 1 hour and 45 minutes. The time difference is half an hour between these two states. With South Australia half an hour behind New South Wales, if a plane leaves Sydney for Adelaide at 8:45 a.m., when would it arrive in Adelaide in South Australian time? Okay, this question seems a lot harder than it actually is, mainly because of the wording, okay? But we have to get straight two things, okay? When the train leaves, okay, when train leaves, in Sydney, it's what? 8:45, as stated in this line over here. How about in Brisbane? Oh, not Brisbane, sorry. Adelaide. In Adelaide, it's half an hour behind. Half an hour behind. Meaning that what? It's 8:15. Okay? 15 a.m. Now, as long as we establish these two things, then it gets simple. Because if we know that the train leaves at 8:45 in Sydney, but in Adelaide it's actually 8:15 because it's 30 minutes behind, then we know that 1 hour and 45 minutes later, which both applies to simultaneously, because remember time runs the same for both cities. If Adelaide is an hour and 45 minutes later, then when do we get? In terms of Adelaide, we would have arrived at exactly 10 a.m. Okay, 1 hour 45 plus 8:15 is 10 a.m. So that's why I calculated that. And that's actually your answer. That's it. It's option B. Now, let's look at Sydney. The train would have arrived at 10:15 a.m. Okay, and from then on, this could have been another way you could have solved it. You could have find out, oh, what is 1 hour and 45 minutes from Sydney? So 8:45, it's 10:15 a.m. But since I know that, not 10:15, it's 10:30. Since I know that Adelaide is 30 minutes behind, I could have just subtracted 30 minutes from that. But because that is a two-step process, and rather it's easier if we just find Adelaide time and then work from there, I've chosen this first method. Okay. All right. Next question. This mystery number has 4 digits. Okay, so we have some number that we don't know. Every digit is an odd number. None of the digits is a 7. Every digit in the number is different. Okay. The smallest digit is in the ones place. The second greatest digit is in the thousands place. The preceding describes 2 possible numbers. The mystery number is the greater of those 2 numbers. What is the mystery number? Okay, let's break down this question. Let's start as we go. This mystery number has 4 digits. Every digit is an odd number. Okay, let's list the number of odd numbers we have. What's possible? 1, 3, 5, and 9. Can we go past that? No, because remember, it's a digit, a single digit. None other digit is a 7. Oh, I should have included 7 in that. But okay, now that we know 7's not in it, it's just 1, 3, 5, 9. Every digit is a number is different. Great. Then the smallest digit is in the ones place. Okay, first rule. The smallest digit, which is 1, is in the ones place. Great. The second greatest digit, which would be 5, is in the thousands place. So because we know it's the 4 digit, we know that the 5 is actually the first number that comes out. The preceding describes the 2 possible numbers. Okay, preceding. What might that be? It can be a combination of this, 5391 or 5931. So from these two, what does it say? The mystery number is the greater of these 2 numbers. So which one's greater? It's obviously 5,931. What is the mystery number then? It is 5,931. So that corresponds to option E, which is why we circle it. Okay, guys, let's look at the next question. If the distance between the centers of the circles marked A and B is 24 centimeters, find the area of the rectangle. Alright, so how do we tackle this question? We start by working with what we know, which is that A and B is 24 centimeters. Now, where is A and B? A and B are known to be the centers of each circle. So if that's the case, we know that A and B is exactly 3 diameters plus, remember I'm talking about 3 diameters here, from this circle to here, plus 2 radiuses at each end to each point, right? Which, if you think about it, 2 radiuses is the same as 1 diameter. So in total, we have 4 diameters worth, and we know that 4 diameters in length is 24 centimeters, meaning that 1 diameter divided by 4 on both sides is 6. Great. Let's look at the next part of this question. Find the area of the rectangle. Okay, if we know the diameter of one circle is 6 centimeters, and there are, how many? 8 circles, or 8 diameters, you can think of it as your length, then length is 8 times 6, okay? So I'm using this knowledge here. 8 times 6 is 48 centimeters. Great. How about the width? Okay. Width is equal to this, which is 3 diameters, or 3 circles worth of diameters. And we know D is 6, so we do 3 times 6, we get 18 centimeters. Great. So now that we have width and length, area is easy, isn't it, guys? Area is width times length, which is equal to 48 times 18. Do this with me. What is 48 times 18? 8 times 8 is 64. 48 times 4 times 8 is 32, plus 384. 1 times 8 is 8. 1 times 4 is 4. So we add it. Oops, I'm running out of space. It's 4618. So 864. So I'm going to write that here, 864. So we've got our answer, 864 squared centimeters, which is option D. Final question. Let's have a look at this one. A boy can swim 2 kilometers per hour in still water. If he swims downstream in a river and the river is flowing with him, he covers a distance of 12 kilometers in 2 hours and 30 minutes. How fast was the stream flowing? Okay. I have to establish first in this question that this distance that he covers in 2 hours and 30 minutes is when he's traveling 2 kilometers plus the stream flow, the speed of the stream. Okay, and I'm gonna call this speed together, or the net total speed, as S. Okay, so traveling S kilometers per hour, in 2 hours and 30 minutes he travels 12 kilometers. Now this is where we pull out the formula S equals to distance over time. Okay, some of you I've been teaching, I've given you the pyramid as so, speed, distance, and time. So whichever we're trying to find for, we cover. So imagine I'm looking for speed, I cover up speed, and I get left with D over T. Okay, so since we know that's the case, speed is distance over time, I know that speed, our S as well, is equal to, what's the distance? 12 kilometers over how many hours? 2.5 hours. I'm going to convert it to decimal place here because it doesn't make sense if I say 2 hours and 30 minutes because 12 is in kilometers, okay? So we're trying to find out speed in terms of kilometers per hour. So we do that. Let's try. What is 12 divided by 12.5? Well, I'm going to get rid of 2.5 and say 25. So instead I have to move the decimal place for 12 to the right side. So I get 120 divided by 25 as well. That's the same thing. We get 4 inside 20. Since 25 doesn't go into 20, you put a decimal point there. Then we say, okay, that's 200. How many times does 25 go into 200? 8 times. So we know that the total speed that they're traveling at, or the boy and the river, is 4.8 kilometers per hour. Okay? But since we know that the boy can only actually travel 2 kilometers per hour, we know that this 4.8 kilometers must be a combination, as the question said, of 2 kilometers plus, what's the other one? If speed is 4.8, the actual river speed must be 2.8 kilometers. Okay? 2.8 kilometers. So, how fast was the river flowing? 2.8 kilometers per hour. Okay? Excellent. Now, let's move on to the key points from this test. Point number 1. When working with questions involving relative information, define values in terms of what you're looking for. What do I mean by that? This I draw from the very first question we did. David, Kim, and Steve one. If, guys, we have information that is relative to one another, that is, David weighs 3 kilograms more than Kim, as in we don't know the actual number of David's weight or Kim's weight or Steve's weight, it's all relative to each other, then we actually find our terms or pronumerals in terms of what we're trying to look for. And we're trying to look for David, right? Can you see that I've stated all these pronumerals in terms of David, so that I can actually use this information so that I can easily transfer the information in as well and find the answer. Okay? So when working with relative information, make sure you've defined values in terms of what you're looking for. All right, point number 2. Time runs simultaneous in all places in obviously maths questions. Let's have a look. In this question, you guys remember that Sydney and Adelaide both show a different time, but the flow of time, guys, even though they might be at different, indicate different times on the clock, the flow of time in these places is the same. So an hour and 30 in Sydney is the same as an hour and 30 in Adelaide. So you can equally add an hour and 45 minutes onto whatever time you're looking at. So don't get confused with that. The flow of time is the same. So time runs simultaneously in all places. And finally, the last point is speed equals to distance over time. And now, it's just a formula, but I want to emphasize this because it should be like bread and butter for you guys. Just pull it out as soon as you see some sort of distance, time, or speed sort of question. In selective preparation, this will always be the formula or go-to formula. So either memorize this triangle or memorize this formula and learn how to manipulate it. Okay? All right.